Hi everyone, my name is Pradyumn and today we will discuss the solutions for today's educational CF round and we'll discuss the first 5 problems, that is from A to E. So before we get started, I will tell you about our courses at TLE Eliminators. So if you are someone who is stuck at solving just 1 or 2 problems per contest, our self-paced courses are exactly what you need. We have structured the program into 4 levels so that you can start from wherever you are, beginner, pre-intermediate, intermediate or advanced. You will learn the most relevant CP concepts through video lectures by experienced educators, followed by carefully curated practice problems combined with guided hints and detailed video solutions that help you understand the why and not just the how. We believe in helping you build real intuition. And if you need more help, then you will get instant doubt support from our high-rated mentors so that you are never left stuck. And beyond learning, you will enjoy leaderboards, gamified progress tracking, internal contests, and PCDs to keep you consistent. Pick the level that fits your goals and start learning today. And if you are not sure that which level you should choose, then you can watch this video to understand how to choose a level. And if you are still not sure, then you can look at the course specific videos which tell you that what is included, prerequisites, outcomes, difficulty and topics. Alright, so let's get started now. Okay, so this was today's contest. We will start with A. So problem A was, consider an n by n grid filled with numbers as follows. The first row contains 1 to n, second row contains n plus 1 to 2n, and so on until the last row. So basically from left to right we are filling the grid. Let us define the cost of a cell as its value plus the sum of its neighboring cells' values. Two cells are considered neighboring if they share a side. Your task is to calculate the maximum cost among all cells in the grid. Okay. So here we have this grid and what they are saying is like n is given to us and we have to make this n by n grid where the first row is 1 to n, second row is n plus 1 to 2n and so on. I'll make a smaller grid, let's say 4 by 4. Okay, and they are saying that for each cell, for some cell the cost is its value plus the neighboring cell's value, right? So for this cell right here, this one, its cost is the sum of these 5 values, right? So we have to tell that what is the cell with the maximum cost. Okay, and n is up to 100 here, right? So actually you could brute force as well. Like what you could simply do is just go through all these cells. Like there are total n square cells, right? There are a total of n square cells in this. So you can just iterate over all of them, right? And for each one of them you can calculate their cost. Okay, and that would probably work because the time taken in that would be n square into number of test cases, that is t. So O of t into n square, that would work because 100 into 100 into 100, which is 10 to the power 6 and which is less than 10 to the power 8. So it would work, right? But that is a brute force approach and we can actually do it in less than that. Okay, so I'll show you how to do that. Alright, so first of all, just notice a few things. Okay, let's say I have a 5 by 5 grid. So my claim is that let's say you have two options. Either you can choose this cell in green or you can choose this red cell. Okay, so which one would you choose? Is there an always clear answer? Like, is one cell always better than that? Like, is red always better than green or green always better than red? Can you say that? So yes, we can say that this red cell is always greater than the green cell, right? Because these numbers are higher. Like if you see the red cell contributors, this like if you look at the red cell, the cost of the red cell, then these 5 cells would add up in that, right? And if you look at the green cell, then these 5 cells would add up. And of course, you can see that the red ones are lower, all of them are lower, right? So they will definitely add up to a higher value, right? So what we conclude is the lower the better. So we need more lower. So lower is better, right? And similarly, if you look at this red and blue cell, so in red and blue, which one is better? Blue is better, right? Because blue is more toward the right. So blue is better than red. Because blue is more toward the right and we have higher numbers towards the right. That is, if you look at these 5 cells, right, they will add up to the cost of the blue cell. And if you look at these red cells, so this one, this one, this one, this one, and this one. So if you compare the blue and the red ones, of course the blue ones will add up to more, right? So you will want more right. So writer is better. Writer is better, right? So you would want to choose a cell which is very low and also very right. Okay. But then why don't you just choose this cell always? The thing is that if you choose this cell, then actually it has 2 less neighbors. Like it doesn't have this neighbor and it doesn't have this neighbor. Whereas if you choose, let's say, this cell, then it would have these 2 neighbors, right? This, like, it would have this neighbor at least, this bottom one. Whereas this cell doesn't have a bottom neighbor, right? So we can easily say that this might not be a good idea. Like even though its value itself is higher than this value, but we are getting less number of cells. So it might depend on the value of n also, right? So let's try to generalize this. Like let's say we have this grid. We have this grid, right? And I will fill in some values. So let's zoom in on the bottom right part because that's where the higher numbers lie. So okay, this one is n square, right? I'll decrease the size of my pen. Okay, so this is n square. This is n square minus 1, right? Then this is n square minus n, and this cell is n square minus n minus 1, right? Now of course you will definitely not choose any other cell. Like you will definitely not choose this cell because it's better to just choose this one, and you will not choose this cell because you would just choose this one, right? So these 4 are the only ones that matter, right? Like if you can see that if we choose this one, then we will get this plus this as our cost. So that is 3n square minus n minus 1, right? Then let's say if we choose this, then we would get these 4 cells, right? So that is, like, I think it is 4n square minus 3 or minus 4, let's say, and minus n, right? And if you choose okay, wait, if you choose this one, n square minus n, then you would get these 4 cells. So it is 4n square and minus 4n minus 1, I guess, right? 4n square minus 4n minus 1 And if you choose this cell right here, if you choose this cell, then you would get 5 cells, right? You would get this one and this one, right? And you can add them up to see that its cost adds up to 5n square minus 5n minus 5, right? So these 4 are the options that we can have to get the cost. Now as you can see, this n square, like this n square term is with 5 in this, right? So probably this one is higher because n square dominates when n is a large number. So like when n is large, then we would definitely choose this 5n square one, and otherwise we can like look at these possibilities and check. Like actually you can see that in sample test cases they have given 1, 2, 3, 4 and 5. So for 1, 2, 3 and 4, the answer is not this last one, right? The answer is something else. 1, 9, 29 and 56. Like if you can see, this is a multiple of 5. 5 into n square minus n minus 1. But these 4 answers are not a multiple of 5. So they are either one of these things, right? But this one, this 95 is a multiple of 5. So we can see that starting from n equal to 5, n equal to 5 and higher, we will definitely choose this one because it has a greater constant term with n square, right? So this is the answer for n greater than equal to 5. So for the first 4, we can say that these 4 are the answers, and for n more than equal to 5, this is the answer, 5 into n square minus n minus 1, right? So this was the optimized approach that you can take, or actually you can just take the the maximum of these for every n, that also works. But yeah, just take care that these formula are only valid for n greater than equal to 3, right? Because we assume that this cell has all its neighbors, but for n equal to 2, this cell is the corner cell, right? So it is not valid for that. So for only n greater than equal to 3, these formula are valid, right? For small n, you can just do brute force. Okay, so this is the answer. For n greater than equal to 5, this is the answer, and for the first 4n, they already gave the answer. So this is it. Okay, so let's look at the code. Okay, so in 10, C in n, if n is 1, then C out 1. If n is 2, then C out 9. If n is 3, then C out 29. N is 4, then C out 56. And otherwise, C out 5 into n square minus n minus 1. Okay, works. So I think you would have gotten the solution. So now let's move with the next one. Move to the next problem. Okay. So problem B is addition on segment. You start with an integer array A, which initially consists of n zeros. You have to perform the following action exactly n times. Choose two integers L and R and assign AI equals to AI plus 1 for each I such that I is between L to R. You are given an array B consisting of n integers. Your task is to choose such values L and R for each action such that after all n actions are performed, it is possible to reorder elements in such a way that A becomes equal to B, and the maximum value of R minus L plus 1 over all the actions is as large as possible. Then what is the maximum possible value of R minus L plus 1? Okay, so what they are saying is, initially there is an array which is equal to all zeros, right? Okay, and then what operation we can do? We can select a subarray. Okay, we can select any subarray. Let's say this subarray we choose, and we can increase the value of all of its elements by 1. So let's say we do this, then all of these 3 elements increment by 1. Okay, so we will do this n times, exactly n times. Okay, exactly n times we can do this, like we will do this exactly n times, this operation, and finally we will get an array A, right? Finally we will get an array which is called A. Now they are saying that we are given, like in the input, an array B, right? An array B is given, and we have to rearrange this array B. We have to rearrange this array B to get the array A. Okay, like basically we have to rearrange this array B into some array A and make this array A using exactly n of those operations. Okay, and in such a way that the maximum value of r minus l plus 1 is maximized over all the operations. So the problem statement might not be very clear. Let us look at some examples. Okay, so 0 5 1 0 1. So let's say we have this array in the input, 0 5 1 0 1, right? So what I'll do is I will rearrange this into this, like 1 1 5 0 0. Okay, so now I can make this array. How? Like what I can do is I can perform one operation on 1 comma 3. This is one operation. Then I can perform one more operation on 3 comma 3. Okay, and like I'll perform 4 operations on 3 comma 3, like into 4. Basically I am performing one operation on 1 comma 3 and 4 operations on 3 comma 3, right? So what is the maximum value of r minus l plus 1 for this? It is 3, right? In this operation I am getting 3 as the value of r minus l plus 1, right? So basically 3 is a possible answer, because essentially what we are doing is we have rearranged this array into this and we are able to get an operation with length 3. So maximum value, like maximum length in these operations is 3, right? And basically that's why the answer is 3. Like there is no way to get an operation with length more than 3, right? Because if you do operation of length 4, then there can't be 2 zeros, right? Like if we have only 5 elements and if we want 2 zeros, then of course we cannot touch these 2 elements, right? We can only touch these 3 elements. So maximum possible operation length would be 3 only, and we are able to get an answer with 3. So the answer is 3. Okay, like my point is that I am able to make this array, which is a rearrangement of the input array, and I am able to make it using the operations, these ones. Like I have to do 5 operations, right? Exactly n operations I have to do. Here n is 5, so I did 5 operations, so 4 of these and 1 of these, and here in these operations I am getting a maximum value of 3 in this operation, right? And I cannot get a better than 3, like I cannot get a value better than 3, so therefore this is 3 is the answer. Okay, then let's say 3 2 1. Okay, so 3 2 1 is the input, and let's say I rearrange this into 3 2 1 only, like I want to work with 3 2 1. So we can make this using 3 operations, 1 comma 3, 1 comma 2 and 1 comma 1. That is, first we will add to both all 3 of these, so 1 1 1. Then we'll add to 1 comma 2, so this becomes 2 and 2. Then we'll add to only the first element, so this becomes 3, right? So 3 to 1 we are getting like this. So we are getting 3 to 1 using these 3 operations, and here the maximum value of r minus l plus 1 is 3, right? So the answer for this input 3 to 1 is 3, because we are able to get a value of 3. Okay, but in the third test case we can see that it is 1 1 1 1 1, right? So the thing is that we cannot really do an operation of 5. Like, the answer here cannot be 5. Why? Because if we do one operation of 5 length, let's say we had 0 0 initially, right? Initially we had 0 0 0 0 0. Now if we do operation of length 5, we'll get 1 1 1 1 1 in just one operation, right? We have gotten this, but actually we have to do 5 operations, right? We have to do exactly 5 operations. So if we perform a length 5 operation, that is L equal to 1 and R equal to 5, then we can't, then we won't be able to do 4 more operations and still end up with this array, right? That's the problem. Like, to make this 1 1 1 1 1 array, we have to do 5 operations, and the only way to do that is to make these 5 operations: 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, and 5 comma 5. So these 5 are the only operations. Like, we have to do these operations to make this 1 1 1 1 1 array, right? And so in this case, the highest value of r minus l plus 1, it is just 1. Okay, so that's why we cannot have the answer 5. Like, even though we have 5 length, like our n is equal to 5, and we have 5 non-zero elements, but we cannot do the operation entirely on 5 length. Okay, because we have to do exactly 5 operations. So if we do an operation of length 5, we won't be able to do more operations. Okay, so that's the problem here. Like, what's the problem? Like, okay, let's say one logic that I can get here is, let's say 1 2 3. Like, here we had this test case, right? 0 0 1 1 5. Like, this test case we had 0 0 1 1 5, and here we notice one fact, that the number of non-zero elements, basically these 0 elements cannot be changed, right? So the maximum possible length would be the number of non-zero elements, right? So here there are 3 non-zero elements, and therefore we can do an operation of length 3 and other operations of 2, like make the array that we want, right? Like, we can perform an operation of length 3 here, and it will become 0 0 4, and then we can perform an operation of length 1 on this one 4 times, so it will become 3, then 2, then 1, then 0. So 4 operations here and 1 operation like this, and we are able to get a length 3 operation, right? But then we saw that not always it is possible. Like, let's say we had this kind of array, 0 0 1 1 3, right? So here, if we do this operation, like if we just take all the non-zero elements and do this operation of length 3, then this array would become 0 0 0 0 2, right? So now we cannot do 4 operations, we have to do 4 more operations, right? Because n was equal to 5, so in total we have to do 5 operations, and 1 we did right here, so we have to do 4 more, but we cannot do 4 more because we have only 2 right here. So it is not possible to do a length 3 operation and still be able to do total 5 operations and make this 0, right? So the number of non-zero elements, this is not the answer. Like, this can be one of the possible thought process, like this is one of the possible thoughts that we can get. Like, this is one of the bounds, that our final answer is at most the number of non-zero elements. number of non-zero elements, the answer cannot be greater than that, right? But it can be less than that also. It can be less than that. And why is that? Because if we just perform an operation on all the non-zero elements, then it might be in that case that we are not able to perform n minus 1 more operations. Like in this case, 0, 0, 1, 1, 2 or 1, 1, 4, let's say. If we do an operation like this, so it will become 0, 0, 0, 0, 3. And now even though we have to do 4 more operations, we won't be able to do that because we have only 3 here. So let me ask you one question, that in what case will I be able to do 4 more operations? Like what is the condition? Like let's say I do this one operation on these non-zero elements, then what is the condition that I can do 4 more operations? Or in general, if I say I have an array of length n, right, and on all the non-zero elements I do the operation, okay, then I will get one array after subtracting minus 1 from each element. So now what is the condition on this array so that I can do n minus 1 more operations? So actually the condition is that the total sum of this array must be greater than or equal to n minus 1. Why is that? Because see, in one operation, like let's say I have 1, 2, 3, 4, 5. So if I do a length 2 operation, then both of these elements decrease by 1. This is minus 1, this is minus 1. So in total minus 2 will happen. Okay. But let's say I do a length 1 operation, then only minus 1 will happen. But my point is that in each operation, the sum decreases by at least 1. Okay. So if we want to do n minus 1 more operations, then the initial sum of this array has to be at least n minus 1. If it is less than n minus 1, then definitely we won't be able to perform n minus 1 operations. Is that clear? Like that's why this test case was failing. Like 0, 0, 1, 1, 4. So let's say I perform a length 3 operation on this and try to make the answer 3. But we won't be able to do that because after doing this operation, it becomes 0, 0, 0, 0, 3. So the sum of these elements is 3. Whereas n minus 1 operations, like we have to do 4 more operations, right? So n minus 1 is 4. So we definitely won't be able to do 4 operations on this, right? So we have to choose the initial length in such a way that we are able to perform the required operations. Like let's say if I just chose these 2 elements on the first move, like on the first move I just subtracted 2 elements, then it would become what? 0, 0, 1, 0, 3. So now the sum is 4, right? So since the sum is at least 4, I can do the operation. I can perform one operation on this of length 1, and I can perform 3 operations on this of length 3, and so it is possible. So answer of 2 is possible because on the first operation I am getting a length of 2. R minus L plus 1 is 2 for the first operation. So we are able to get 2 as the answer. But if we try 3, then it is not possible, right? So basically my condition is that after subtracting, like after doing first move, the sum should remain at least n minus 1. Okay. So let's say I do a first move. Like, okay, let's say the initial sum of this array is S. Okay. The initial sum of this array is S. Now, if I, like on the first move, if I do an operation of length X, like I subtract minus 1 from total x elements. So the length of my first move is x. So this sum would become what? S minus x, right? And we want that this s minus x has to be at least equal to n minus 1, right? So basically x has to be less than or equal to n minus s minus 1. So the length of the initial operation cannot be more than n minus s minus 1. Okay, that is the condition. So if you are able to like take all the non-zero elements, then it is fine. Like let's say we have the test case 0, 0, 2, 3 and 10. Okay, so here if we just take all the non-zero elements, then also it is fine. Like then also the array would become 0, 0, 1, 2, 9, and its sum is what? 12, which is greater than or equal to 4, right? So in that case it is fine. So your answer would be the number of non-zero elements, right? But if you are not able to do that, that is if the sum is too less, then your answer would be this, n minus s minus 1. So basically your final answer would just be minimum of n minus s minus 1 comma number of non-zero elements. Like see, in this case if you try to apply the formula, like okay, if the initial array is this 0, 0, 0, 0, 0, 2, 3, 10. Okay, so initially the sum is 15. Sorry, n minus s minus 1, s minus n minus 1. From here you would get x is less than or equal to s minus n minus 1, right? So if you try to apply this formula on this thing, you would get 15 minus 5 minus 1, which is 9. So x has to be less than or equal to 9. That is our constraint. But we just want x as 3, right? Because there are only 3 non-zero elements. So x can be only 3. So the minimum of 3, 9 basically. We will take the minimum of 3 and 9, which is 3. So that's why we are doing the minimum of s minus n minus 1 comma number of non-zero elements. This is the final answer. Okay. So I hope you got the explanation. I will show the code now. Like the code that I wrote was pretty messy. Like I deleted the 0 elements and all. But finally what I am doing is minimum of n comma s minus n minus 1. Okay. Like here n is the number of non-zero elements. Like actually I just deleted all the 0 elements from this array and then I did the thing. So here n is the number of non-zero elements. So the answer is min of n comma, where n is the number of non-zero elements, comma sum minus n. So initially I set k to n, like I stored the value of n before changing it. So sum minus k plus 1. Okay. Like this implementation is pretty bad, but yeah, the formula is pretty clear. I think the minimum of sum minus n minus 1 comma number of non-zero elements. Okay, and make sure to have sum, and in long some people took int in the sum and they got hacked. Okay, so anyways, let's move on to the problem C now. Quotient and remainder. You are given two integer arrays q1 q2 to qn and r1 r2 to rn, as well as an integer k. You can perform the following operation any number of times. Choose two integers x and y such that 1 is less than equal to y less than x less than equal to k. There exists an index I such that qi equals to x upon y, gi of x upon y, and there exists an index j such that rj equals to x mod y. Then you can remove qi from the array q and rj from the array r. If there are multiple instances, then you can only remove only one. Calculate the maximum number of operations that you can perform on the given arrays Q and R. Okay, so what they are saying is we have been given two arrays Q and R. Okay, so let's take a sample. Let's say 565 and 717, 565 and 717, right? And what we can do is we can choose any two elements from these two arrays and we can remove them if we can find two integers x and y such that x by y equals to 6 and x mod y equal to 7. Okay, and x mod y equal to 7. So like basically the point is that we can delete 6 and 7 if we can find two integers x and y such that x by y is 6 and x mod y is 7, and also both are less than equal to k. Like the condition is that y is less than x, y less than x, and both should be less than equal to k. Okay, that is the condition, right? And they have to be greater than equal to 1 as well, greater than equal to 1. Okay, so you have to find two numbers x and y such that both are less than equal to k and greater than equal to 1, and y is less than x, and x by y is 6 and x mod y is 7. So if you can find two such integers, then you can delete 6 and 7, right? So this is one operation, and you have to report the maximum number of times that you can delete. Okay, right? So this is the problem. This is the problem that you have to solve, that you have to find the maximum number of times that you can delete this pair of Q and R. Okay, so basically to delete some Ri or Qi, let's say if we want to delete an element Qi from the array Q and some element Rj from the array R, then you have to ensure that there are two numbers such that x by y ka GIF equals to Qi and the x mod y equals to Rj. Okay, so actually what you can say using this is that, see, if you divide x by y, then quotient is Qi and remainder is Rj. Then by the simple mathematical formula that the number equals to quotient into divisor plus remainder, right? This is the simple maths. So we can write that x is equal to Qi into y plus Rj, right? We can write this. This is what we can write, that if Qi is equal to x by y ka GIF and Rj equals to x mod y, then we can write that x is equal to Qi into y plus j. So if we divide x by y, then the quotient is Qi and the remainder is Rj. Okay, so so now what we can actually say is that if we have a y, like let's say we want to delete two numbers from this array. Okay, let's say I want to delete 6 from Qi and 7 from Rj. That is, I want to, like, the value of Qi is 6 and value of Rj is 7, right? So now I just need to find two values of x and y. Like I just need to find a value of x and y such that this is satisfied. Okay, so if I just put any y, then I'll get some x, right? And so I can just use those x and y and delete this value. So let's say if I just put y as 1, right, then I'll get x as 13, 6, like 6 into 1 plus 7, 13, So I can simply choose x equals to 13 and y equals to 1, and this satisfies, and therefore I can delete 6 and 7. Right? Wrong. Okay, this is wrong. Why? Because if you see, if you find out the value of x mod y, it turns out to 0, and x by y, it turns out to 13, which is not the same as 6 and 7. Like, we wanted x by y to turn out to 6 and x mod y to turn out to 7, but this is not matching. So what's the problem here? The problem is that in this equation, one second, I'll clear this. Yeah, so the problem is that in this equation we have one more constraint, that the remainder is always less than the divisor, right? This is also one more constraint. So our value of y has to be at least rj. Okay, so now let's try to do it again. Like, if we want quotient to be 6 and the remainder to be 7. Okay, so since the remainder is 7, then y has to be at least 7, right? So let's just keep y as something, let's say 9. Okay, then what does x turn out to be? X turn out to be 6 into 9, 51 plus 7, sorry, 54 plus 7, 61. So x is equal to 61 and y is equal to 9. So now if you find out the value of x by y, it turns out to be 6, because 61 by 9 is 6, like 6 point something, and if you take the floor it is 6, and x mod y turns out to be 7, right? So this value, like this pair of x comma y, is valid. Okay, this 61, 9 pair of x and y, it is valid. And why is that? Because x is equal to qi into y plus rj is satisfied. That is 61 equals to 6 into 9 plus 7. That is satisfied. And also this rj is less than y. Okay, so this x comma y is a valid pair. And also if and only if this k is at least 61. Like, we have to also ensure that these both quantities are less than equal to 61. Okay, like we have to ensure that both x and y, that is x, actually x will be greater, right? X is greater than y. So you have to ensure that this value of x is less than equal to k, right? So only then would it be a valid pair, right? But in this test case they have given that the value of k is 10, right? So x is, like, this pair of x comma y is not valid because x is exceeding the limit. Okay, so we saw this. So now let us know how, let us think more. Like, we have some qi, we have some rj, right? And we want to check, we want to determine that can we delete this, like can we delete this pair. So to delete this we have to find two integers x and y such that x is equal to y into qi plus rj, and also this y should be, or rj should be less than y. That means y should be greater than rj, right? So these two conditions should be satisfied. And we also need that the value of x should be less than equal to some k. So the value of x should be less than equal to some k, right? And like basically what we can do is we can choose any value of y which is greater than rj. That is, we can choose rj plus 1, we can choose rj plus 2, or any value we can choose, and correspondingly we will get some x, right, which will produce the quotient and the remainder. So any value is valid, but we want that this x should be less than equal to k. So we would try to minimize the value of x, right? We would want that the value of x is as small as possible. So what we will do is we will choose, like, if we want x to be small and we can choose the any value of y, then of course we will choose the smallest value of y, right? We will choose y to be small as well. And what is the smallest value of y? it is rj plus 1, right? So if we want to make some quotient and remainder, then we'll choose y to be remainder plus 1, and so the value of x would come out to be something. Like if I just choose the value of y to be rj plus 1, then the value of x would turn out to be rj plus 1 into qi plus rj, right? This is the value of x, and we want that this value should be less than equal to k. This value should be less than equal to k, right? This is the condition. Like if we want to eliminate some value, like if we want to eliminate some pair qi comma rj, then the value of rj plus 1 into qi plus rj, this should be less than equal to k. This is the condition. Like this is the final condition that whether or not we can delete some value pair rj comma qi or not. Okay, so here you can see that, let's say from these two arrays, let's say we want to delete 2 and 8. So q equal to 2, q is 2 and r is 8. So if we find out the value of this, it will be 9 into 2 plus 8, which is 9 into 2 is 18 plus 8, 26, right? And since this value 26 is less than equal to 42, that's why we can delete 2 and 8. Like if we want, then we can delete 2 and 8. That's what the condition means. Okay, this is the master condition that we can use. Okay, so now how do we actually find out the maximum number of pairs that we can delete from the array? Like how do we actually delete the array, like delete the elements in such a way to maximize the number of elements that we delete? How do we do that? So basically the condition is what? The condition is, like if I want to delete some value, if I have this is not working properly, but yeah, so if I have some value quotient I, like let's say I have this array q and this array r, right? And for now just assume that they are in sorted order, like both are in increasing order. Okay, so let's say I want some element qi, I want to delete this, element qi. Then what is the condition on this r? Like what is the condition? The condition is that if I choose some rj here, then I can delete this qi using this rj if and only if rj plus 1 into qi plus rj is less than equal to k. So this is the condition, right? So basically if I fix a qi, then there would be an upper limit on the value of rj, right? Like let's say I have k equal to 100 and I have, let's say, qi equal to 10. Okay, then I want that whatever rj I choose, rj plus 1 into 10 plus rj should be less than equal to 100, right? So what is the value of rj that is possible? Like 1 is possible, right? Because 21 less than equal to 100. Then 2 is possible, right? Because 32. 3 is possible, 4 is possible, 5 is possible, 6 is possible, then 7 also possible, 8 is possible, but 9 is not possible, because as soon as you reach 9, this value becomes greater than 100. So basically our rj has an upper limit, like rj should be less than equal to 8. That is the condition if we want to delete a 10, right? So basically if I choose any qi, I have this condition, and this condition means that there is an upper limit on the value of rj. That is, there are some values of rj, like I'll get a number. Basically I can say what? From here I can say that, let's say I write it like this, rj into qi plus 1 plus qi should be less than equal to k. So this means that rj should be less than equal to k minus qi divided by qi plus 1. Wait, is this right? Yeah, I guess this is right. So basically for some value of qi that we choose, we have a range of rj, that is an upper limit on the value of rj that we can choose. So let's say in this array, like let's just sort this array 1 2 2 4 5. 1 2 2 4 5 and 8 8 9 9 100. Right. So let's say if I want to delete this 2, and here k is 42, right? K is equal to 42. So if I want to delete this 2 from this quotients, then whatever r I choose, r plus 1 into 2 plus r has to be less than equal to 42, right? So this means that r has to be less than equal to 20. This is the condition. So basically I have these 4 possible values, right? But let's say I want to delete this 4. Okay, then what is the condition? That r plus 1 into 4 plus r should be less than equal to 42. So from here you can get that r is less than equal to 7.6. Okay, you can see like r plus 1 into 4 plus r less than equal to 42. You can write this as 5r plus 4 less than equal to 42, and so r is less than equal to 7.6. So for 2 you have these 4 possible values, but for 4 you don't have any value because all these elements are greater than equal to 8, right? So if you just have all the elements in increasing order, okay, so this is quotients and this is remainders. So for a small quotient you can have a large remainder as well, right? So let's say for this element you have these possible values of r, then for this element you have these possible values, then for this element you have these possible values, right, and so on. Then basically for the higher elements in Q you have less number of possibilities, right? So greedily what you should do is you should first deal with the higher ones first. Like basically this is the highest quotient, right? And it has only one possibility, let's say. So what you will do is you will look at this and see if your this remainder, like if your lowest remainder can deal with this, right? And if it can, then you will delete both of these. That is the strategy. Like basically the strategy is, since higher quotients have tighter bounds, on the value of the remainder, deal with them first. Right, that is the strategy. Like here, if I take an example, 5 4 2 2 1, 5 4 2 2 1, and the remainders we have are 8 8 8, like 8 8 9 9 and 100. Right. So if I want to delete this 5, okay, k is 42. So if I want to delete this 5, then r plus 1 into 5 plus r should be less than equal to 42. So here we get r is less than equal to 6. Okay. So for 5, I don't have anything, so I'll move ahead with 4. So for 4, I already told you, 4 r should be less than equal to 7.6. And again, we don't have anything to delete this 4. So this 4 can't be deleted. Then for this 2, we have the condition that r plus 1 into 2 plus r should be less than equal to 42. So this will give me r is less than equal to 20, right? So to delete this 2, I can use any value which is less than equal to 20. And as of now, this 2 is the highest element. So I can just use the lowest one for this, because the other elements will have lower bounds, right? So I can simply use this remainder to delete this 2, right? So I'll move this pointer one step ahead. That is, I have used this remainder already. Okay. Then for this 2, I can use this 8, because this 8 is also less than equal to 20. And then for this 1, for the 1, again we will find out that r plus 1 into 1 plus r less than equal to 42. So r has to be less than equal to 21. Oh, sorry. I think I messed the calculation. R should be less than equal to 40 by 3, which is 13. Right here, 13 should come. And here, if we want to delete this 1, then R has to be less than equal to 21. And so we can use this 9 to delete this 1. And so we have deleted 3 elements. So the final strategy is we can we can delete the higher quotients first. So basically we'll reverse sort the quotient array and we will sort the remainder array, and we will keep deleting one by one. And the condition to delete is this, that rj into qi plus 1 plus qi should be less than equal to k. Or we can write it as rj plus 1 into qi plus rj is less than equal to k. Right. So this is the entire solution. Okay, so I'll show the code now. Alright, so yeah, I'll sort this quotients array in decreasing order and remainders array in increasing order. And P1 is the pointer for the remainder array, that is till where, like from where have we not used the remainders, and ans is the counter, right? So for int I equal to 0, I less than an I plus plus. If P1 equal to n, then break. Then basically we have used all the remainders, so we break. If r of P1 plus 1 into Qi plus r of P1 is less than equal to k, that is for the current quotient Qi, if the smallest remainder is less than equal to k, like if this value is less than equal to k, that means we can use the smallest remainder to delete this highest value of Qi, and so we will do that. That is, we have used this remainder, so P1 plus plus and ans plus plus, and finally we will print the answer. Okay. So this was the solution to problem number 3. And I hope you understood this. If you did not, then you can ask in the comments. Okay. Now let's move on to problem 4. So problem D was very casework type of problem, and many people hated it, but I'll solve it anyways. So the problem says that let us define a value of a string consisting of letters x, v, I as follows. The value of x is 10, the value of v is 5, and the value of I is 1 or minus 1. Minus 1 if the next position contains a letter x or v, and 1 otherwise. The value of the entire string is the sum of the values of all the letters in it. You are given a string of characters x, v, I and question mark, and asked Q queries about it. In the ith query, three integers are provided: cx, cv and ci. The number of available letters x, v and I respectively. What is the minimum value of the string that can be obtained if all the question marks are replaced with the letters x, v and I, so that the number of used letters does not exceed the number of available letters of each type? Okay, so what they have here is a problem which says that we have been given a string. Okay, like there's a string which, let's say, only contains x, v and I. Okay, the value of x is 10, the value of v is 5, and the value of I is either 1 or -1, right, depending upon. So if the I is followed by a v, like if there is an iv or there is an ix, then the value of this I is -1. Okay, and otherwise the value of I is 1. That is, if this is the last character, then the value of I is 1, or if it is followed by an I, then also it is the value of I is 1. Okay, and the total value of the value of string is the sum of the values of all of these elements, right? All of the individual numbers, that is the total value of the string. Okay, so the thing is that in the input string we have been given some question marks as well. Like they have given us a string where there are some x's, there are some v's, there are some i's and some question marks, right? And we have to fill these question marks with either x, v or I. Okay, but also they have given us a limit. Like we cannot use, like let's say the query is 231. Okay, so the thing is that 231 means that we have only 2 x's, 3 v's and 1 I. Like we cannot put more than 1 I or more than 3 v's, right? So basically that is the condition, that like they have given us a limit in each query and we have to put these numbers into the question mark in such a way that the value of the final string should be the minimum possible. Okay, like if I put these letters right here in the question mark, then we have to put in such a way that the final value is minimized. Okay, so in this problem there are many things going on, so let's break them down one by one. Okay, so the first thing to observe is that x and v are equivalent. Okay, like except for their values, like x is 10 and v is 5, but other than that they are equivalent only. Okay, in the sense that if I have an x, like instead of putting an x, I can always put a v, and that will give me a lower cost, right? A lower value. I want to minimize the value, right? So if I am putting, like if there's a question mark, and I am putting an x here, right? But I have v also in my pocket, then I'll put v instead, not x. Okay, because there is no purpose of putting an x. It will not help us in anything, because even in iv this value is -1, and even in ix this value is -1. So putting an x has no benefit. Okay, that is one point. All right, then another point is that putting an I in the question mark is always better than putting a v. Okay, like what I am saying is, let's say we have some string. Let's take a test case only. I question mark v. I space v. Okay, so here either we can put I or we can put v. Okay, so if I put I, then its value can be either -1 or 1, right? I don't know which. Like for this string I know that it is -1, but in general I don't know that will it be -1 or 1, right? So in a general string I have, let's say these values are filled and this is a question mark. Then if I put an I here, then it can be either -1 or it can be 1. But if I put a v, then its value will be 5 only, right? Okay, but it might happen that there is an I here, right? There is an I here, and initially its value would have been 1, but now if I put a v here, then its value is -1. So putting a v gave me a profit of 2, like this, but the value of v itself is 5, whereas if I had put an I, then it would be 1. So I am incurring a loss of 4 to get a profit of 2, and that is not good, right? Like my point is that if I put a v here, then possibly we can get a benefit that this 1 becomes -1, like this I value becomes -1 rather than 1. So here we get 2 profit, but in return of that we are putting a v, right? So we are incurring a cost of 5, and if we had put an I here, we would just have incurred a cost of 1. So we are taking 4 cost more to potentially get 2 profit, and that will always go against our favor, right? Like net loss here in this case is -2. So it is always better to put an I, because its value will be less than v. Like its value is much less than v. So this 1 is much less than 5. So even though I can get a profit of 2 potentially, but still it is not worth it because the difference here is 4, right? So putting an I is always better than putting an v, and putting a v is always better than putting an x, right? So of course, so now what we can now what we know is putting an I is better than putting a v is better than putting an x. So if we have enough i's to fill all the question marks, then we will fill all the question marks using i's, right? So for example here, like basically that you get my point, right? If we have enough i's to fill all the question marks, then we'll put only i's because they have the minimum value. So even though putting a v might benefit us by a factor of 2, like by a difference of 2, but its value is 4 more than I, so we won't put that. Okay, that is one thing that is clear. So first we will exhaust all the i's, we will put all the i's that we can in the question marks, but if still there are more question marks, then we will put all the v's, and still if there are more question marks, then we will put all of the x's. Okay, but now where to put the I, v and x? Like now we know the count, right? Like let's say we have 9 question marks, and we have 5 i's, we have 3 v's, and we have 6 x's, right? Then we will basically put 5 i's in the string. Like first we'll put 5 i's, so out of 9, 5 would be i's, so 4 are remaining, and then out of this 4, 3 would be v's, right? So 1 is remaining, and that one would be x. So in the string we would put 5 i's, 3 v's, and 1 x. That is for sure. That's what we concluded, that is for sure. But where to put these 9 characters in such a way to minimize the final cost or the final value, right? we need to minimize the final value. Like we have to put these 9 elements to minimize the final value, right? So how to do that? Now that is like we can just follow a greedy approach there. Okay, like I'll just take an example. Let's say we have this string right here, dash dash iv dash vxiv dash. Okay, so and let's say test case we take 1 2 1. Okay, so there will be one. Okay, let ivx 1 2 and 1. So there are 4 blanks, right? There are 4 blanks and I have 4 characters, so it is equal. So I have to put 1 I, 2 v's and 1 x, right? So okay, now the value of v and x is fixed, right? The value of v and x is fixed, like value of v is 5 and value of x is always 10, right? The only thing that can change is the value of this I. It can be either -1 or 1. Okay, the value of this I can change. It can be either -1 or it can be 1, depending on where we place it. Okay, so if we place this I on a special blank, okay, then it is -1. Like what I am defining as special blank is special blank is a blank which is followed by a I, x or a v. Like a special blank is a blank followed by x or v. Okay, so here you can see that okay, this blank is a special blank, right? This one is not special. This was also not special because this is empty right now, right? So this one is special blank. So if you put an I here, then you'll get a value of -1. Okay, that is for sure. So I am defining this special blank like this. Okay, so you want to make sure that you put as many i's on special blanks as possible, right? So initially you have this blank as a special blank because it is followed by a v, right? But the thing is that this is a blank, right? So if you put a v here, okay, then this blank would become special, right? That's the thing. If you put a v here, like if you put a v or an x here, then this blank would become special, right? So I can call it potentially special. This blank is potentially special, right? Because if I put a v or an x here, then it would become special. So this blank is special currently and this blank is potentially special because if we put here v or an x, then it will become special, right? Okay, cool. So basically for this string I have one special blank and one potentially special blank, right? So potentially special means if I put a v or an x there, then it will become special. So of course I would put v and like my v or an x there, so that because I want to maximize the special elements, right? I want to maximize the special blanks, so that if I put a I there, then it would become -1, right? So my point is that um, this blank is potentially special, this blank is special, and the rest of these two are not special, right? So what I'll do is I will first put this v here. Okay, like since this blank is potentially special, so I will put a v here to make it special, right? So now I have two special cells in my string, right? I have two special cells in my string, and then now I can place like, okay, what I have to do, I just placed one v, so I have to put one v more and one x more and one I also more. So I, of course, I'll put in special cell. So I'll, like, either I can put I here or I can put I here, whatever, doesn't matter. So let's say I put I here, and let's say I put a v here and an x here. So this is how I can do. So I had two special cells, but I had only one I. I had only one I, so only one of those special cells was used, right? So basically I got a profit of -2 here. Like this I would be 1, like the value of I would have been 1, but since I put it on a special cell, its value is now -1. So I can say that I got a profit of 2, that is my value decreased by -2, right? So basically my final value would decrease by the number of i's that I place in special cells. Okay, and multiply by 2, because the profit is -2 for each cell, right? So the number of I that I place in special cells into 2, that is my profit. Okay, so I can actually write this as, like, let's say I have 5 special cells and I want to insert 7 I's, right? So then my profit would be what? -10, because I have only 5 special cells. So I will insert all of these like 5 I's into 5 special cells, and the other 2 I's I'll place somewhere else which are not special. So I'll get a profit of -10. But let's say I have 7 special cells but only 5 I's. So I would have to, like, what I'll do is I'll place all of those 5 I's in those 7 special cells, right? And so I'll get a profit of -10, and the other 2 special cells would be filled by X or V, and so there is no benefit of that. So profit is -10 only. So basically the final profit is just 2 into the minimum of number of special cells, comma number of I's that I place. Right. So this is kind of some logic that we are getting. Okay. So we have to count the number of potential special cells and also the number of current special cells. Okay. And then we can try to get that how many of those potential special cells are we able to convert, right? Like, let's say for the same string, like, what's the string? I'll again copy it. It was dash dash iv dash vx iv dash, right? So here you can see that we have one potential special cell, because I can fill V or X here, right? So this is potential, and here I have one current special cell, because here it is V, right? So current special cell is 1 and potential is also 1, right? But what if I have like the number of I is 4 and the number of V is 0 and the number of X is 0? There are 4 blanks and I want to fill 4 I's, 0 V's and 0 X. So in that case, this potential is not converted, right? I am not able to put this V and X here to convert this potential into a current, right? So current remains only 1. So basically number of special cells finally in this case remains only 1 and the number of I's that I put is equal to 4. So my profit is basically min of 1 comma 4 into 2. 2 into min of 1 comma 4, which is 2. Okay. So that is our profit, right? So like, but now what if I had let's say 1 V, 2 X's and 4 I's? In that case also I will actually choose 4 I's and 0 V's and 0 X's, right? That's what I told you. First I will exhaust all my I's, then if needed then I'll choose V's and then I'll choose X. But since I want to fill only 4 cells, I will fill them with all 4 I's. I told you, right, that putting an I is always better than putting an V. Putting an I is always better than putting a V. So here also it would be same only. But what if I have something like 2 I's, 1 V and 2 X's? So in that case, I would finally put 2 I's, 1 V and 1 X, right? So now I can put this V in such a way that this potential converts to current, right? So this one potential I can convert using this V. So now my special cells become equal to 2. Special becomes 2 and the number of I that I put, the number of I's that I put, that is also equal to 2. So our profit actually becomes equal to 4, right? So that's what the idea is. But now there are some edge cases, okay? There are some edge cases that, okay, I'll take this example. I guess in this example, the edge case is, okay, it is not covered. So let's say we have something, let's say we have VI, question mark, question mark, question mark, or question mark, let's say 2 question marks. Then let's say IV. Okay, this is our string. Okay, and let's say I's I have 0, V I have 2, and X I have 0. Okay. So in this case, what you will say is current I have 0, like in this string, current equal to 0, like the cells which are currently special equal to 0, and potential equal to 1. Like this cell can potentially be special if I put a V right here, V or an X, right? So potential equal to 1. Okay. So now if you try to find the answer for this case, then like what would you call your profit? So since you have 2 V's, then like the potential can convert into current, right? So you can convert a cell into a special cell. So current becomes equal to 1, current becomes equal to 1, right? But you have no I's to put. Okay, you have no I's to put, so what you will do is min of current comma I. So you will say it is 0, the profit is 0. But actually you can see that if you put a V right here, okay, if you put a V right here, then this cell gets converted from normal to special, right? And there is an I also here. There is an I also here. So you can say that the profit actually was -2. Like if I put a V here, then this cell converts to special, right? And there's an I here. so it becomes minus 2, right? So actually what we were doing mistake, like what mistake we were doing in our calculation was that we were not considering these i's which are um, which are preceding this blank, right? Like we were not considering these i's which are followed by a blank. Okay, so those i's can also get converted. Okay, we were only considering the number of i's that we are placing, right? Like in this case we are placing 0 i's, so we were taking min with 0, but actually we have these i's also which are followed by a blank, right? So they can also be converted, so we will also count them in our calculation. That what we will do is our profit equals to 2 into min of the number of special cells current, like the initial current plus the number of cells that we were able to convert using V and X. So min of current comma the number of i's that we put plus i's followed by a blank, i's followed by a blank. Okay, so that is our profit. Like initially I was not considering these i's, right? So this is our profit. Okay, but now the final point is that how do we calculate the potential? Okay, like let's say I have xi and dash 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 dash, and then let's say ixv. Okay, so in this string what is the potential and what is the current? So current, there are none, like there are no blanks which are followed by an x or a v, right? So current is none. And potentially how many can there be? Like if I, let's say I put an x right here, I mean x or a v, let's say v right here, a v right here and a v right here. So in this case this cell becomes special, this becomes special, and this I also becomes special, right? So basically we have three potentially special cells. So my potential is equal to 3 for this case, right? Like the maximum number of special cells that we can get is 3. So potential is 3. But what if there was not an I here but a V? Like let's say instead of, wait, yeah, okay, so instead of this string, let's say here we had a V. Okay, then what is the potential? Then let's say if I put a V here, then this becomes potentially this becomes special. If I put a V here, this becomes special. But if I put a V here, then there is no point. So like the potential here would be 2. The potential is 2 because now this is not preceded by an I, right? So the potential is 2. Okay, so this is how you can calculate. Like you can have, you have to do some case work and you can calculate the potential for each case. So I will try to do all the case work. So the first case is that basically I have a sequence of blanks. Let's say I have 5 blanks. Okay, and before it there is an I, and after it also there's an I. Okay, so basically I, then odd number of blanks, and then I. So in this case, let's say X. Okay, So in this case, what is the potential? So for 5, I have 3 potential, right? I can put a V here, and a V here. So these 3 cells get converted. So for 5, I have 3. So if I have 7, that I would have 4, right? Like if I just add 2 more cells, right? Then if I put a V here, V here, V here. Sorry, there are 6. So if I put a V here, V here, V here, and a V here, I would have 4 special cells. So for 7 I have 4, for 3 I have 5. For 5 I have 3, for 7 I have 4. So in general, if I say for x, I would have x plus 1 upon 2, right? Then let's say I have like I have I, and in between I have an even number of empty cells. Then what is the potential? Then the potential is like I can put a V right here to make this special, and a V right here to make this special, right? Or I can put a V here to make this special. Only one of those two possibilities. Like I can either make this and this special, or I can either make these two special. But I can only make at most 2 special. So in that case, my potential is 2. So if x is 4, then potential is 2. So I can say x by 2. So if I have I, even, and I, then the potential is x by 2, right? So this is the first case where I have both i's. Then let's say I have I and a v. Okay. If I have a v here, and let's say odd, so I, odd, and v, then what is the potential? So maybe like, okay, this is the current, this is already current, so I'll put an I here, right? This is already current, so I cannot put a V here, okay, so I'll put an I. But then, okay, I can put a V here to make this special, and a V here to make this special, right? Or I can put a V here to make this special, but only one of those two things. So for 5 I have 2, like for 5 I am getting 2. So for odd I will get x minus 1 upon 2. Like if I have I and v, I will get x minus 1 upon 2. And let's say if I have even, okay, if I have 4 only, then I think I'll get 1. Like here this is already special, so I'll put I here. I can't put v here, so if I put v here, this becomes special, and if I put v here, this becomes special. Okay, so for 4 we are getting 2, right? If I have 4 blanks, then we are getting 2 special, like 2 potentially special, right? So for I, even, and v, the answer is x by 2. The potential is x by 2, right? Then similarly we can deal with the other cases. I have lost the great. Okay, so I'll again start from the beginning. Like I'll iterate through the cases. So first I had I, odd, and I. Okay, so in that case, what would it be? Let's say I, then 5, then I. So if I put a V here, a V here, and a V here, so all these 3 cells would become special, right? So x plus 1 upon 2. Then if I have I, even, and I, then I think it was x by 2. Then if I have, let's say, I, odd, and V, then I think it was x minus 1 by 2, right? Like if I have I here and 5 blanks here and a V here, then of course this is already special, so I'll put an I here. So I can put a V here to make this one special, and V here to make this one special. So these two become special. Or I can put a V here to make this special, and a V here to make this special. So in this case also only 2 becomes special. So for 5 I am getting 2, right? So x minus 1 by 2. And if I have even I even v, then also the answer is x by 2, because for 4 we are getting 2, right? Then let's say we have v odd I. Okay, so v odd I, let's say basically we have a v here, then odd number of elements, then I, odd number of blanks. So here we can put a v here to make this one special, then we can put a v here to make this special. So we are getting 2 specials. So basically x minus 1 upon 2. And if we have v even and I, then we are getting, like, we can put v here to make this special, v here to make this special, and v here to make this special. So we are getting 3 specials. So x by 2, right? And then final case, v odd I, v odd v, and v even v. Okay, so for v odd v, so this is 5 cells. If I have v odd v, then okay, this is already special, so I'll put I here. Like, I'll never put a v here, so I'll always put an I here. So this will become special. Like, sorry, if I put a v here, this is special. If I put a v here, this is special. So for 5 we are getting 2 more special cells. So x minus 1 upon 2 and v even v. So if I have even number of cells between this v and v, then here I'll put I, of course, because it is already special. Then I can put a v here to make this special and a v here to make this special. Okay. So basically we are getting only 2 more special cells, right? So in this case you will get x by 2 minus 1, because for x equal to 6 you are getting 2. Okay, so these are the all 8 cases that we can calculate, right? And this is how you can calculate the potential. Like, you can just look at every block of question marks in your string. Like, just look at every block of question marks in your string and the previous cell and the next cell, and just check that how many potentially you can make, like how many cells you can potentially make special using this arrangement, right? And there are the 8 cases for that. So this is how you can calculate the potential. And of course the current you can calculate. Current is just the number of blanks, like blanks followed by x or v. So those are the currently special ones, and you find the potential. And also you will count the number of special I. Special I's are what? Those are those I's which can be, like, basically the I's which are followed by a blank, right? So here if you put a v, then automatically this becomes special. Like, automatically we get a profit of minus 2, right? Like, in the minimum we are doing cur, comma, number of i's that we put plus special I. So you can just count the special I also, that is i's which are followed by a blank, right? So you can just calculate these 3 values: the potential cells, the current cells, and special i's. And finally you can calculate your profit, which is minus 2 into the minimum of this, right? So this is a bit of casework problem, but yeah, you can get this elegant solution. And also, what if this question mark is in the starting? Like, there is one edge case. Like, I handled these cases where there is a question mark, like I, then question marks, then I. I, then question marks, then I. But what if there's a question mark at the beginning or at the end? Like let's say dash 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 V and I then dash dash. Then what about this? Like what about the potential of these cells? So actually what I just did was I appended like V at the beginning of this string, like whatever string I have given as the input. Like let's say I have been given S as the input. So I just appended V in the beginning and I at the end. Okay. So this won't change the answer. Like it will only increase the answer by 6. Right? And then finally I can just subtract -6 from the final answer. So in this way, the question marks will always have something surrounding them, right? So I can just use these 8 cases to calculate the potential. Okay. So that's what the problem looks like. So I'll just show the code now. Like you will have to, I think about this problem to understand my solution more clearly. Okay. So yeah, I just take the input n comma q, c in n comma q, string s, c in s. Then these variables are not used, just ignore them. T1, T2, they are not used. And yeah, I just insert v in the beginning of the string and I at the end, right? And I increment the n and I initialize the answer with -6. So like in this ans variable, I am storing the initial answer. Like all those letters that are not question mark, I will just store there some of the value. Okay. Like what I'll just do is, whatever blanks I have, I'll ignore them. Okay. And then I will just calculate the value of the current string. Okay. Like for this string, in my answer, I will store 5 plus 1 plus 5 plus 10 plus 5 plus 1. Like I'm just assuming that the value of this I is equal to 1. So initially the answer will contain this. Okay. And finally, if this I gets converted to special, then I'll just do -2, right? I'm already doing -2. That's why I am counting this I as 1 initially. Like unless it is followed by a V. Like if this I is followed by a V, then I am counting it as -1. And if this I is followed by a blank, like let's say there was an I here and a blank here, then I'm counting it as a 1 for now, right? So like that's what I'm doing here. For int I equal to 0 to n-1. If it is 10, I'm incrementing by 10. If it is v, I'm incrementing by 5. If it is I, then if the next element is v or x, then I am doing -1. Otherwise, the next element is blank or I, so I'm doing +1. So even if I is followed by a blank, I am for now counting it as a +1, right? And in the end, like okay, I just did from 0 to n-1, and the last element is I, right? Because I pushed back I here. So this ans plus plus. Okay. So in ans, I just have the sum, right? And yeah, then I just make this vector which contains some information. Like basically for a test case, let's say I have x, v, I, then dot question mark, then x, v, question mark, x. So I will convert this into a vector which is x, v, I, 4, x, v, 2, x. Like this string is converted into this vector, and like for x I have stored the value as 3 into 10 to the power 6, and for v I have stored the value as 2 into 10 to the power 6. Like this is an integer vector. This is a vector of int in which I am storing this x as 3e6, v as 2e6, I as 1e6, okay, and 4 as 4, right? So like because I'm just storing the count of this question marks, right? And it cannot be 3e6, 2e6 or 1e6. it can be only as much as n, and the limit of n is 3, 5. So I just denote the value of x as 3, 6, the value of v is 1 as 2 is 6, and value of I is 1 is 6. So basically I convert this string into this vector x v I, then 4 question marks, so 4, then x v, then 2 question marks, so 2, and then x. So I just convert this representation to make it a bit easier. Okay, so I have this vector of int v. So if s of I is question mark, then if the last one was question mark only, so I'll increment it, otherwise I'll push back 1. So this is a new run of question marks, right? Less than equal to 5 means it is not I, v or x. So if the last, like if v dot back is I, v or x, then I'll push back 1, otherwise I'll just increment the back, right? Else if I get v, then I'll push back v. If I get x, then I'll push back x, and if I get I, I'll push back I. Okay, so this is how I am making the vector v, and then I am finding the potential. Okay, so for every block of question marks, I am adding to the potential. So the current equal to 0, potential equal to 0, and special I equal to 0. So I'll just iterate over the vector, and if it is I, v or x, then I'll continue, because I just want to deal with the question marks, right? Now so this is a question mark now, like if I don't continue, so I'm at a question mark. Now if the next element is a v or an x, then basically I have currently special, right? Like if I am dealing with this block right now, so vi would be 4, and so if there's an x here or a v here, then this cell is special. So I am just doing curl plus plus, right? And if v of I minus 1 is I, like if I have an I here before this blank, so special I, like this I can be special, so special I plus plus. Okay, and then I just have these 8 cases. I mean, I just combined some into a single case. Like you can see clearly that, okay, if I have I odd v and I even v, so if I have I odd v, I have x minus 1 by 2, and if I have I even v, I have x by 2. So actually I can write this as the floor of x by 2. Okay, and similarly if I have v odd I and v even I, so for v odd I, yeah, same thing. So I can write this as floor of x by 2, right? And in this case I can actually write this as floor of x minus 1 by 2. Okay, and for the first case I can write this as floor of x plus 1 by 2. So actually we can combine these two cases into one only. That's what I did here. So if I, v and even, then potential plus equals to v of I by 2. If I, v and odd, then potential plus equal to v of I by 2, or v of I minus 1 by 2, same thing. If I and I, then v of I plus 1 by 2, as you can see here. Yeah, if I and I, then x plus 1 by 2, and if v and v, then x minus 1 by 2, right? And if v and I, then just x by 2, right? So that's how we just calculate the potential. Okay, and now in the query, like I'll handle the queries. So I have XVI, I'll see in XVI. If I is greater than or equal to C, that is, if I have enough number of i's to fill all the blanks. So C is the count of blanks. So if I is greater than or equal to C, then I will print answer plus C. That is, ans was just the initial value plus C was like the number of ones, right? Like I'll insert C i's and each I has cost a value of 1. So I'll do plus C. But the special cells, like I had cur special cells, right? So when I insert I into them, they will give me -2 profit. So I'll do -2 into cur, right? So else means I don't have enough number of i's. Okay, so I'll use all the i's, and remaining I'll have c minus I. So in the remaining elements I will have to put x and v. Okay, so some potential would get converted into current, right? So this cur I am like this in this variable I am storing that after putting the x and v, what is the new number of curs? Okay, so that would be just the initial number of curs plus min of potential comma remaining elements. So like rem stores x and v, like the number of x and v that we are going to put, and pod stores the potential. So the number of potential that get converted is the min of pod comma rem. So I'll add that to the current special elements, right? So cur stores the number of special elements currently, right? And cv stores the count of v, and cx stores the count of x, right? And finally the answer would be ans plus 1 into number of i's plus 5 into number of v's plus 10 into number of x's, and minus 2 into the plus the profit basically. So minus 2 into min of cur, that is the special cells, comma number of i's that we put plus the special number of i's. Okay, like that's why I wrote here that our profit, okay, it is lost I guess. Yeah, the profit is just 2 into the min of current special elements, comma I we put plus special number of i's, the special i's. Okay, the number of special i's. Okay, so that's the entire code. So this was quite tricky question, like this problem was quite tricky, that is very casework type, right? So yeah, this was D, and if you have any doubts then you can ask in the comment section below and I'll answer it. Okay, and finally we have problem number E, binary strings and blocks. So it is loading. Yeah, define a block in a binary string as its continuous substring of characters of the same type that cannot be extended either to the left or to the right. For example, in string 1100011111, there are 3 blocks 11000 and 1111, right? The substring from 7th character to the 9th character is 111. Like this, basically it is not a block because this is a block. Okay, we call a string beautiful if we can remove exactly one block from it so that the resulting string consists of an odd number of blocks. For example, the string 11001111 is beautiful because we can remove the block from the 3rd to the 5th character, resulting in the string this, which consists of one block. The string 1010 is beautiful because we can remove this block, so it will contain 101. This string 0000 is not beautiful because if we remove this block then it will become empty, right? Then you are given an integer n and m constraints, the ith of which is described by a pair of integers li, ri. We denote the substring of the string s from character L to character R as s L to R, that is SL plus 1 up to SR. Your task is to count the number of binary strings S of length n meeting the following condition. For each I from 1 to m, the string Li to Ri, the string S of Li to Ri is beautiful. Okay, so the question is that they have defined a beautiful string. Like for a binary string, they have defined beautiful okay in such a way that if we can remove a block from a string and finally that string would contain odd number of blocks, then it is beautiful. Okay, so let's say we have 1 0 1 1 0 1 0 0 0 1. Okay, so what are the blocks? So the blocks are these: 1 0 1 1 0 1 0 0 0 and 1, right? So these are the blocks. So how many blocks we have? 1 2 3 4 5 6 and 7. Okay, so from here actually we can just remove any block in the middle. Like I can remove either this block or this block or this block or this or this one. Like let's say I remove this one, then these two would get combined, right? So I have removed this one block and these two become one. So basically initially I had 7 blocks and now I have 5. So I still have an odd number of blocks, right? So if initially I have odd number of blocks in my string, then I can simply remove anything from the middle, right? And I'll still have an odd number of blocks. But initially if I have even number of blocks, then what? 1 1 0 0 1 1 0 0. So I have initially 4 blocks, right? 1 2 3 and 4. So initially if I have 4 blocks, then how do I remove a block such that it contains odd? So what I can do is I can just remove the last one, right? So now it contains 3. Like initially it contained 4, now it contains 3. So if I have an even number of blocks, then I can just remove the last block to make it beautiful, right? And if I have an odd number of blocks, I can remove any middle one. I can remove a middle block and it will become beautiful, right? But in the odd case, what if there is no middle? Like basically if I have only one block, right? The only case where I cannot ensure odd is where there is no middle in this odd case. That is when I have only one block. Let's say 0 0 0 0 0. So in this case, what can I do? Like the only thing I can remove is this entire thing. But then I would have 0 blocks, which is not even, like which is even, not odd. So it is not beautiful. So this string containing only one block is not beautiful, and all the other strings are beautiful. Like my point is that a string is beautiful. Oh, okay, a string is not beautiful a string is not beautiful if it has all same digits. Okay, that is the thing, that a string is not beautiful if it is either 0 0 0 0 0, like any number of zeros, or any number of ones. So these two types of strings are not beautiful, and all the other binary strings, they are beautiful. Okay, that is the thing. Alright, so now that is out of the way, we can understand that what is the problem asking us to do. So it is asking us to count the number of binary strings of length n which satisfy some constraints. Like what they have given is, they have given us some ranges, and to ensure that all of those ranges, those substrings, they are all beautiful. That is, for all of these ranges, the elements are not all the same. Like there should not be a 1 1 1 here or a 0 0 0 here, right? That's the thing. Like we have to ensure that there is no 1 1 1 here, there is no 0 0 0 here, and also there is no 1 1 1 here or a 0 0 0 here, right? That's what we have to ensure. So now, how do we actually like ensure that, and like how do we actually count the number of such strings? That is the question. Okay, so you can actually look at the binary string in terms of block, right? That's what they've defined right now, that if you have some binary string 1 1 0 0 1 0 1 1 0 0, then this is one block, this is one more block, right? These are the blocks in this binary string. And basically what is the condition? The condition for beautiful is that no constraint should be entirely contained in one block. Right? I can write this like this. Like, let's say um, I have the condition that this is the constraint, right? So I want that 1 1 1 should not be there and 0 0 0 should not be there. So that means none of the blocks should contain this range in its entirety, right? Like, let's say for example I have 1 1 1 0 0 0 0 1 1 1. So this is a block, right? And let's say if a constraint was this, like if this was a constraint from 4 to 6, right? And this block is from 4 to 7. So this 4 to 7 contains the entire 4 to 6, right? And that's why it is not beautiful, right? So we can say that no block should contain an entire constraint, an entire input range basically. Like basically from like whatever string you create, okay, the blocks in it, like this is the block 1 2 3 5 and 6 7 and 8 8 8, right? So these are the 4 ranges, and in the input there should be no range which is a subset of any of these ranges, right? So if there's a range in the input 3 4, then this is a subset, like 3 4 is a subset of 3 5, and therefore it is not valid. Like that substring would not be beautiful, right? So this binary string would not be valid. Okay, so you just want to count the number of binary strings which satisfy this property that no input range should be contained inside a block. Okay, so actually what you can do is try to build the string block by block and keep ensuring that you don't add a block which contains an entire range. Okay, like let's say you have 1 1, like let's say you want to calculate the number of strings of length I. Okay, like let's say I is, let's say for now 7. So you want to calculate the number of binary strings, number of valid binary strings of length 7, right? So either it will end with a 1 length block, or it will end with a 2 length block like 1 1, or it will end with a 3 length block 1 1 1. Like a 3 length block means there is a 1 1 1 here and a 0 right here, or a 0 0 0 here and a 1 right here, right? So that's the thing, that either it is a 3 length block, or it is a 2 length block, or it is a 1 length block, or it might be 4 length block as well, or 5 length, or 6 length, etc., right? But the thing is that if you have a constraint which is like this, then your final block cannot be like this, right? Or like this, because in that case this range would be entirely contained in this block. That is not possible. So the only possible thing is that you have a block of length 1 like this, or you have a block of length 2. Sorry, block of length 2 means 1 1 and 0 like this, or you have a block of length 3 0 1 1. So, I mean 3 ones and a 0 right here, right? There are only 3 possibilities, that either you have a block of length 1, a block of length 2, or a block of length 3, right? And so you can simply use a kind of DP here to find out the answer for length 7. Okay, like let's say you already know the answers from 1 to 6. Like you already know that how many binary strings are valid of length 4, that is DP of 4, let's say. Okay, then if you say that you are having a block of length 3, so how many strings can you have, how many valid strings can you have with a block of length 3? Like let's say you have this string 1011. Okay, so DP of 4 would contain this string, right? Like DP of 4 has all the strings that are valid of length 4. So this is a valid string, right? 101 is valid string. So if you want to make a string of length 7 which has last 3 digits as a block, so basically 000, right? Because this digit is 1, so you have to have 000 here, right? And let's say if you had some string which is like 0010, then you would have to have 111 here to make a block of length 3. So basically for every string in this DP of 4, I will have one corresponding string of length 7 which has a block of length 3, right? So this DP of 7 would either be like DP of 7 is the number of strings, right? DP of 7 is the number of strings of length 7. So either, like for this constraint, if this is the constraint, then either it can be of block of length 1, like either it can end in a block of length 1, right? Or it can end in a block of length 2, or it can end in a block of length 3. But it cannot end in a block of length 4, right? Because in that case, the entire thing would be overlapped. So we have 3 cases, either length 3, length 2, or length 1. So for length 3 we have DP of 4. For length 2 we have DP of 5. And for length 1 we have DP of 6. Right? That is a transition. Like I'll just give an example. Okay. So let's say we have this 4 and I have this constraint right here. Okay. So what is the DP of 1? Like for the first element, there are 2 possibilities. So DP of 1 is 2. Then for the first 2 elements, there are 4 possibilities, right? Then for the third element, like either it is a block of cell like length 1, right? That means for every possible string in this, like there are 4 strings, right? 0 0 0 1 1 0 and 1 1. So for every possible string I will have one possible string of length 3, that is 0 0 1, then this 0 1 and 0, 1 0 and 1, and 1 1 and 0. So these 4 strings are ending in a block of length 1, right? So block of length 1 are 4. Then let's say I want a block of length 2. That means I want these two to be same, right? So in that case, either here can be 1, so here it will be 0 and 0, or here it can be 0, so here it will be 1 and 1. So block of length 2 would be 2. Like there are 2 possibilities. So DP of 1 essentially, right? So we are just doing DP of 2 plus DP of 1, and yeah, plus block of length 3 also is possible. So that is just 2, like either 1 1 1 or 0 0 0. So DP of 2 plus DP of 1 plus 2. So finally we get 8, right? So finally we get 8. Okay. So DP of 1 is 2, DP of 2 is 4, DP of 3 is 8. What about DP of 4? So either we can have a block of length 1, right? Actually we can only have a block of length 1. because we want that these two digits have to be different. So we can only have a block of length 1, that is the dp of 4 would just be dp of 3. So dp of 4 is also 8. So final answer is 8. Right. Like this was kind of a dry run of the above approach. Like my entire point is to calculate the number of strings. To calculate the number of strings of length I, the value string of length I, you can see that what is the length of the last block that you can have. Like either it is of length 1, or it can be of length 2, or it can be of length 3. But you have to ensure that no range is enclosed in any of these. Like let's say in the input we have this range right here, and we have, let's say, this range right here. Then you can either have this block, or you can have this block at the end, or this block at the end, or this block at the end, right? You cannot have this block. Okay, so basically for all the active ranges, like this is the active range and this is the active range. So for all the active ranges, you will just store the maximum L value. Like for this, the L value is here, and for this range, the L value is here, right? So this is the maximum L value, and that's why you cannot have until here. Like either you have only 1 or 2 length or 3 length or 4 length blocks. You cannot transition using a 5 length block. Okay, that's the entire idea. So you can simply store the maximum L value, and you can transition using either a 4 length or a 3 length or a 2 length or a 1 length block. Okay, and that's how you can calculate dp of I. So I think this might be a somewhat clear. Like let's say this was max L. Okay, then you can, if you want to calculate dp of I, then you can either have 1 length block, so which is dp of I minus 1, or you can have 2 length block, which is this dp I minus 2, or you can have a 3 length block, which is dp of I minus 3, right? Or you can have this one as well, which is dp of max L. So you can go until dp of max L. Okay, so this is how you can calculate dp of I. Alright, this is what your transition looks like. Like the entire idea is that we need to ensure that there are no blocks which overlap with the input range, right? So this is the entire idea, and to transition like this you can simply use prefix sums. Okay, so yeah, this was the entire approach, and this might not be very clear to those who are not well versed with dp. So if you did not understand much of it, then I think you should practice little bit more about block dp. I mean, block dp is not a name, but like you should practice dp a little bit more, and I think then you will get the idea of this. Okay, otherwise you can also ask in the comments that if you have a particular doubt, you can ask in the comments also. Okay, but yeah, so I'll show the code now. Okay, so I think I have the code in VS Code as well. Yeah, so this is the code. I am doing int nm, c in nm, vector of int v. So this v actually is storing, like if I have a pair l comma r, in the input, then I am just storing the value of L at that R value. Like let's say I have these ranges, this range and this range, 1 2 3 4 5 6 and 7. So at 5 in the V vector I am storing 3, and at 7 I am storing 5. Actually I am storing the maximum L value for each R. Okay, so that I can keep track that what is the maximum L value over all the active ranges. Okay, so in this V of R I am storing L, like in zero indexing I am just doing V of minus 1 equals to max of V of R minus 1 comma L minus 1. Then I have this DP array of length n and prefix array, prefix sum array for the DP. So DP of 0 is 2, that is for the first bit there are only two options, 0 or 1, right? And max L I have that for the active ranges what is the maximum value of L. Okay, so for int I equal to 1, I less than I plus plus, max L equals to max L comma V of I. So like if we are at the ith element, like all those ranges which end at the ith element, I have to include them as well, right? Like if I was at 4 currently, then this range was not a part of it, but now when I move to 5, this range is now active range, so I have to consider this L also. So I just did max L equals to max L comma V of I. Okay, so now if max L is greater than 0, then what does that mean? That means that I have some constraint, like basically if this is max L, right, that means there is some range like this. So I can only take either a block of length 1 or length 2 or length 3, right? That means either this DP or this DP or this DP. So I can go like I minus 1, I minus 2 up to max L, right? So DP of I would be DP of I minus 1 plus DP of I minus 2 up to DP of max L. That is the prefix up to I minus 1, the prefix sum up to I minus 1 minus prefix sum up to max L minus 1. Like the term after this has to be cancelled out. So prefix of I minus 1 minus prefix of max L minus 1, right? So this is what I have done here. If max L equal to 0, so that means I can transition from anywhere until 1, right? Like if max L equal to 0, that means either the block is of size 1, so DP of I minus 1, or the block is of size 2 or of size 3 or size 4 or size 5 up till here. So I can take DP of I minus 1 for size 1, DP of I minus 2 for this, DP of I minus 3 for this, DP of I minus 4 or DP of I minus 5, or like basically we can take till DP of 0, right? But actually this is not allowed. Like the entire range being one block, that is not allowed. Okay, because the max L is this, max L is 0, that means there is a range, and the entire 0 to I being one element would definitely violate that range. So basically in this case DP of I is same thing, like DP of I minus 1 plus DP of I minus 2 up to DP of 0. Okay, so basically prefix of I minus 1. Otherwise max L equal to minus 1. So max L equal to minus 1 means we can have this one as well. Like we can have this entire thing as one block as well, that is all zeros or all ones. So we have two more cases to account for. So prefix of I minus 1 plus 2. Okay, so this is what DP of I is, and we can simply update prefix of I. Okay, and finally the final answer is just DP of n minus 1. Okay, so this was kind of a standard problem on DP, like where you have to build the array like block by block. Okay, so like for dp of I. For dp of I, you can calculate that either this is one block or this is one block or this is one block, and that's how you can do the casework. Okay, so this might not be very clear, I feel, if you have not practiced dp much. So if that is the case, then you should go ahead and practice more dp. And yeah, this problem was pretty nice but also standard. Okay, so if you still have any doubts, then you can ask in the comment section. I had like quite a bit migraine last night, so I could not take it live. So I'm uploading the video right now. Okay. But yeah, this was the fifth problem, and I hope you understood this solution. And thanks for watching, I guess. Bye bye.